is that there is such a pathway. If you don't believe in supernatural phenomena, there has to be. But we haven't. There are a lot of gaps in our understanding as to what that might be. So we're trying to work out, a nice continuous pathway.
And it might take 1 trillion planets, each with exactly the right conditions.
Well, so it could if there's a bottleneck, if there's a hard step. Right? I suppose the hard step is making some ribosome that can replicate itself. That, in principle, could be so rare that, exactly like you said, we could be unique.
There are a lot of possible universes, so it could be any of those.
It could be. Or, on the other hand, it could be that every step along the way is very easy and is almost inevitable given a suitable planet. In which case, there may be hundreds of millions of planets with life.
What's your intuition at the moment?
So I used to refuse to answer that question, but
sorry.
I'm sort of coming around to the idea that all the steps might be easy because, and this is purely based on extrapolation, that every time we look at a particular step that looks hard because we have no idea how to solve it,
there's a solution.
Eventually there's a solution and it ends up looking really easy. And there haven't been any exceptions to that so far, so if that continues.
Right. And how have you been, first of all?
Great.
Good.
He's alive. He almost died or something.
I heard. But was it as unexpected, almost dying?
Yeah, it was a close one.
Really?
We have a new aorta.
Now he's more than
that sounds
Yeah, they were watching the thoracic area because it was...
Right.
And didn't expect to even think of anything until the spring. He was having an appointment in the spring at follow-up.
I thought vortex would be nice, but they insisted on that.
Coffee? Would you like some coffee?
Yeah.
Coffee, yeah? Milk?
And no, just black. Thank you.
Anyway, it's back at one night.
It just busted one night? No.
Yeah.
No.
What's that?
It busted one night?
It flew.
I mean, so it wasn't you felt a little sick over a period of time?
Well,
it was just
it must have been leaking because it was 2 days. But
but one night he just got and he was operated on that night.
But they fixed it by drilling a little hole here and putting this whole thing in, which is
really
amazing.
Wow.
Yeah, that was a stent, and that was not open. That was not open surgery.
So there's no stop for all of this.
You have new internal wiring done through the exit plug?
Right.
Well, they just put another pipe inside the old bulge out one.
It's running like a new conduit in the old conduit?
Yeah.
Yeah. It's like it inflates on the inside. Thank you.
Wow.
Some coffee, Gloria? Coffee? Some coffee?
Oh, it would be tea, but if you have a tea, otherwise water.
So the thing is to be near a place like MGH.
Right.
Well, that's why I think
that's where
the original surgeon didn't want to go to Dubai.
He's telling me it's a great place to work.
Yes.
If something bad happens, it's good to be able to. It's really good. Yeah.
Yeah, that's what the condition of life.
What hospital do you live nearest?
Well, well, in New York, it's easy. I have my selection. But being in the...
Sinai still good? That's where my father was.
Yeah, there's lots of good hospitals, as long as there's no traffic. If they're lighting the Christmas tree, you're dead no matter what happens. Because you can't get anywhere, unless the hospital's in your house. But since I live in the island, the Virgin Islands, it was tricky because I had the flu and I fainted. And I said, how am I going to get... There's no hospital for hundreds of miles.
Right.
There's a hospital, but just
What
by name only.
What about a helicopter lift?
But to where?
St. Thomas is
Yes, what's the range of a helicopter?
Well, I can go to St. Thomas, but there's...
nothing there that's good.
They practice this form of medicine referred to as unga bunga, which is not the latest. It has sort of the version of a stent is a bone through their nose, but yes.
So let's see.
Miami,
Miami.
but that's 2.5 hours by plane. And I didn't like the idea of traveling.
No tunnel.
Marvin, when you're looking at the concept, how do you describe in intelligence deception? What's the basics? Because anything that is if you're trying to design the AI systems, at some point you would always say that if you wanted to have a system that was smart as a 2-year-old or a 3-year-old. Now, most 3-year-olds turn out to lie. And one of the systems psychologically, right, is the fact that you know it's intelligent if it's able to lie.
Oh, why?
Yep. Lie.
I
The
don't
kid's
remember
not-
that concept.
Well,
That's pretty good.
kids don't. If kids who never lie aren't very smart, they're not very intelligent, right,
But
Gloria?
their kind of lying is what is called confabulation. It's more like trying to plead, well, until they get a little older, then they do definitely.
At some point, when they say that the shit on the floor wasn't me, it was the dog. They
That's
point.
confabulation.
Okay.
I mean, that's a kind of lying.
But it's a kind of it's deception. Is where I started to go. It's a definitely deception where you you send out a fake message to see if you get an answer that has high benefit for low cost.
One of my first cases when I was in medical school at the Bellevue psychiatric division, and they were this psychiatrist was demonstrating how this drunk guy was lying, was confabulating.
Right.
So he said, how we had a great time last night. I was not blind cute. The drink was great. Oh yeah. And then about a second later, he said, "Hey doc, who's pulling whose leg?" So, anyway.
I was reading something about young chimpanzees playing cooperatively, but I can't remember what age that is. They guess what the other one wants and they tend to share things. And then when they're a little older, they stop that.
But that's
more selfish.
But that's more cooperation and the lack of cooperation than actual deception.
Well, guessing that somebody else wants something that must be pretty abstract.
That's abstract, but you're not sending out a false message. You're trying to, I think, interpret what the other person's mind, reading the other person's mind, what's potentially the group.
Oh, right. Great. So this article didn't say when they start to lie.
So if you're making an
pretending that you don't have the food or something.
So I was trying to think if when Danny was building a thinking machine and you were building artificial intelligence things, did you guys ever think about the necessity for a machine to lie, to in fact be intelligent? Because it would be a lower cost solution to some of its problems. Give an answer that you'd accept and leave it alone. As opposed to Danny's expression was he always wanted to make a computer that was proud of him.
Of Danny?
Yes.
Of the program?
That's awesome.
And in the games theory, that's what I was saying, how do you think about, and not only in biology, you're dealing with deception all the time and all types of signals, right? The cells are sending out, HIV or anything else is sending out a deceptive signal, so it's accepted.
Poker, yeah.
Sorry?
Poker is.
It's poker's bluffing, right, most of the
Well,
time?
that's lying.
Yeah, yes. Yeah.
Well, Push Thing had pieces had one robot was actually helping another one build a chair. But I don't think one of those early projects involved trying to fool the other robot. It was hard enough to get them to do anything at all.
Right.
So we never got into deception and that sort of thing. But I wonder what age children start to lie.
Well, or in a game strategy, cells, at what basics do cells start to send out fake messages, disinformation, or camouflage?
That's interesting. I mean, we already have models where cells are in competition with each other. So basically, a model for a cell can grow by eating its neighbors, by sucking out similar molecules. So once you've got competition, it seems like the next step should be what you're talking about, right?
Yes. So, but what Seth describes it as free energy. When you're trying to take the free energy in your cell argument, that's what you're doing, right? You're getting all the benefit of that cell growing up to today cheaper by eating it. So it seems that the first strategy would be to hide, whether you hide in junk or whether in computer programs, I would think that if you assume that the underlying structure was an algorithm, whether it be protein folding or any type of program, if your algorithm was known to the competition or the predator, then you're dead meat by definition, because if once he can read you, there's no reason he shouldn't be able to figure out the strategy to get you a free energy that you've built up. So your first strategy would be to either hide by filling your surroundings with junk, increasing the signal to noise.
Running is useful.
Yes, yes. But that's not deception, right?
When the SETI people build these big antennas that talk to people 10,000 light years away, will they send jokes or what could you send that says, "I'm not here, don't bother"?
That's right. Nobody here but us chickens.
Yes.
So one possibility is to have a repeated interaction where there's a possibility of mistakes. So we're in some repeated cooperative relationship, we're choosing to help each other, but sometimes when I try to be cooperative and do the cooperative thing, a mistake happens and actually I'm selfish by accident. That if you could tell, you can differentiate accidents from real mistakes, that's great, and so then selection would favor strategies that sort of forgive mistakes because they're not predictive of what's going to happen next. But this is exactly an example of the thing that he's talking about, where once an agent has in place a strategy that says, I forgive accidents, then it opens the door for a new strategy that makes accidents on purpose.
That's right. That's a good idea for human level. So I make you believe I didn't mean it. I didn't mean it.
Right. So, but eBay does that. Right. So eBay has a reputation concept where some of the frauds should be detected by a third party. It
reminds me, in Japan, it used to be that if you were drunk and got in an accident while driving, that was an extenuating circumstance. Of course I got in an accident driving. I've been drinking. Oh, okay. Sorry, I interrupted you, please.
Send them the genome for a crocodile.
They'd say, what an awful place.
Yes. But in terms of if you've seen anyone do work, really, the difference or similarities between biological viruses and deceptions, strategies, and computer viruses and deceptions, because my sense is that they're very similar. Whether it's, again, noise to signal or signal to noise, other ways of making believe you're, two computers, sort of a shake hands, right? The concept is, I have to know who you are. Over repeated interaction, you have to understand you're really friendly. There should be some signals back and forth, not only saying I'm still in contact with you, but when someone's eavesdropping, a third cell or a third computer, you want to make sure that they don't either understand what you're saying, but if they tamper with our communication, protein-wise or any type of, I should be able to tell that someone, in fact, was looking or playing, and that three-party game becomes very complicated. So the analogy between computational deception and signals and biological signals, I haven't seen it. I don't know if you did.
No, I mean, viruses always latch on to cellular receptors, right, which are usually used for cells to talk to each other. So they're sort of using that channel to go in and infect cells. But I haven't ever heard of, say, a cell having a fake receptor that it could use to, suck in and kill a virus right away.
Immune system.
Well, but it doesn't.
It's not tricking
Is there
the
anything
virus, right?
analogous
It's
to
just
that?
killing the virus.
Does the immune system trick? I don't know. Does the immune system trick the virus?
No, it detects virus and figures out that it's not what it's supposed to be. It's not
The
something
virus, if the
temporary.
virus would tell the story, the virus would say they tricked me.
Yeah.
They made me blind, so
Everything
they
was
said
fine. That's right. It seemed like a perfectly good cell to infect, and then something came along and dismantled them.
Sometimes the immune system turns on cells.
Yeah.
So that you get these
Autoimmune
autoimmune
disease. Yeah.
So let's go back to bacteria. So they would have these restriction enzymes. So they would actually mask their own sites in the genome, and then if the virus comes in and is not protected in these places, they could cut it there. And so then deception of the virus would be to mask the sites. I don't know if they...
Or just not have them.
Or not have them.
How
So
big
them,
is the small?
Thank you very much.
maybe a few hundred, maybe less than 1,000 base pairs. What's the smallest virus? The virus particles that depend on other viruses, less than 1,000 bases, I would say.
There are, yeah, so the sort of parasitic or associated viruses can be as small as a few hundred nucleotides. Viroids.
What are they called?
Viroids.
Oh, so it's pre-virus or is it a virus?
It's just
There's no
it's like a
delineation.
little RNA that just sort of it carries along on the on an existing virus, might get packaged in the same particle. So it doesn't really. It's like a parasite.
It doesn't
along
encode
with-
for its own viral shell or anything like that.
Right.
The virus also doesn't do that typically.
You use cellular machinery for its replication and then get recognized by something in the viral code and get packaged and transmitted.
But if you were going to try to find the sort of the early form of a deceptive practice in biology, how would you think about it?
So going like way back.
Yes.
So I don't know. I mean, we were talking about these things emerging spontaneously in experiments with just RNA. But then, once you have things compartmentalized in cells with membranes, it's not really obvious how you would make viruses in that situation.
Because they have to go from cell to cell.
Right.
And that's hard.
It's hard for RNA, but maybe just because we don't really understand how it could happen. I mean, there are RNAs that can recognize membrane surfaces, so maybe that would be enough at some level.
In artificial life, like computerized artificial life, I guess there's Tom Ray's Tierra program. This is again a long time ago. One of the things I'm not saying this is a great model for artificial life, but one thing that did happen is it's basically a program where you have these pieces of code that are competing for resources to reproduce themselves. So you have self-reproducing pieces of code, and then they compete for resources to see who does better. But one thing that happened very rapidly was these kind of virus-like pieces of code that basically they were shorter, they had less code there than the other ones, and they were just using some other existing self-replicating piece of code to replicate themselves. So it was really, it was a very viral kind of behavior, and it happened almost immediately. It didn't take, after just a few generations. It started
What
happening.
surprises me so much is you take all the computers in the world, you take the world by bed and all of that stuff, and it's a huge computational power, but there's no spontaneous emergence of viruses yet. All the viruses are made artificially by people. All the defense against viruses are made artificially by people.
Is that true, Marvin?
I guess so.
So you don't have the sources of variation.
Yeah, it's,
Unless you call Microsoft Word actually to be a virus, right?
I talked to IBM people. So the immune system that they have is also made by people. I think once they would have an automatic immune system, that could be a program that could also produce viruses if changed by somebody.
It also might be hard to install new software. If your computer had its own self-generated autoimmune system. It's like, no way are you installing new software.
Yeah, I'm not doing that.
Forget it.
But it's very funny because the computer scientists tell me they're lost. The battle with the hackers is kind of lost because you always get a message, update the software. Half of the people update the software, half don't. And the hackers just have to look at that to see where the weakness is, and then they can infect half of the people.
They have to do an update.
Yeah.
Well, particularly since the message to update the software is being sent to you by a hacker who's actually sending you the software.
I always get these messages saying you should update. How do I know this?
Well, biologically, how does that happen? I'm saying in the virus world, when it says you should change yourself, they usually you ask your friends or your neighbors, is this a safe cell? There's always normally a reputation authority. So in the system, how does cells attempt to say, is this cell, is the instructions, is the signal I'm receiving a real signal? Well, I guess one of the arguments make if you find in a cell in the wrong place, right? You're a liver cell and you shove up in your pancreas, you should kill yourself, isn't it, right? Because your neighbors seem not to be on your wavelength. Was that not a good idea? Was that accurate?
No, I mean, probably most cancer cells sort of escape from a tumor and try to colonize somewhere else, right? End up getting killed because they're in the wrong place. They're not sending out the right signals. They clearly don't belong. And so then the surrounding cells send out signals telling them to kill themselves. And, of course, that breaks down as soon as you get a mutant that doesn't start killing itself.
Right.
That's sort of the opposite of deception in some sense. It's an escape that as opposed to tricking someone, you kind of trick yourself into not listening to the signals that are being sent to you to kill yourself.
There's no real fake.
The default strategy.
That's a real strategy. You turn off a strategy. You're not sending out any fake message. I think deception has to have fake something.
Perhaps I think it's the inverse. That's not.
Of course, it's
but
something.
there is so a lot of let's see, when viruses infect cells, the immune system recognizes typically that cell as an infected cell because it will be displaying bits of the virus on its surface. Right? And a lot of viruses do things. Essentially, they send out signals saying, no, it's okay.
Right.
So that's a very common strategy.
Everything's
So
all right.
that's the sort of a first deception.
Yeah.
There's no intent. But do they send out, how is that done? Do they send out random signals and eventually some of them live? Or is it a...
No, they'll make molecules that mimic normal cellular components, but which are signals that might so do things like prevent the display of those viral peptides, or otherwise they'll put signals out on the cell surface that will make that cell look
normal?
Normal.
Right. So it seems to be very similar to computer things. That's what.
Yeah.
That's what computers do.
The computer things are very similar to what's happening in nature.
Okay.
Time ago.
Yeah, I mean, actually, in some sense, just even when if Apple sends you free software updates, in some sense, it's just a virus, right? Because updating your software on an older computer inevitably makes it run more slowly. And their goal is simply to get so much new software in the computer that you have to buy a new computer. I mean, this is actually true. I mean, it's not even. It's true of Apple as well.
Every new Microsoft was slower than the previous one.
Yeah.
The hardware got better, the software got worse.
So updating your software, I mean, it's all kind of like a scam on the part of the computer companies to put their new software into our computers. So
That's
that we
what
have
you
to buy a
think.
new
It's actually a
computer.
scam for the future computers in mind.
Yeah, that's right.
The future computer had an intent to be born. That would be one of the arguments.
There's an interesting difference, it seems to me, between the biological viruses and the computer viruses, which is sort of what you were saying, but it's that the origination is totally different, where the biological ones are emergent as a result of selection.
Evolution versus intelligent design.
Exactly. And
So
so
not very intelligent, semi-intelligent.
Well, yeah, some of the most virulent viruses were not supposed to be virulent, right? What was this one in the 1990s? This guy, he just meant it to kind of slightly infect a whole bunch of computers and just lay low. But because he made a mistake in programming it, it infected a bunch of computers and then went viral and infected vast quantities of computers. And so the effect was not intended to bring down all these computers.
But has there ever been you were saying there's never been a naturally emergent virus, but has there ever been just an error in a design virus that actually made it better? Not a human error. But
well,
that one described.
but that's what that was a human error in the design of the virus.
Yeah.
But you could imagine, like a copying error that actually made it worse. Has that ever happened?
So I believe, so this, you must be the expert, but I believe computer programs that people write cannot mutate in the way as DNA and RNA in order to give something reasonable.
Well, they're living in an environment with all this error correction.
Well, not really. I mean, they just actually, it's just
Yeah,
very
if you write
accurate.
down a
The
C
transcription
program.
is extremely accurate.
No, but what I mean is, if you write down a C program and you say,
Yeah.
now I make a random, I flip a bit somewhere,
Yeah.
that will never do anything better.